Hello everyone, introduce myself. This is Abid. I am a math teacher. In our channel, now I am going to discuss our 10th class mathematics. Before going to start our topic, we have to know about the basic concepts numbers. Already you have learned in previous classes from LKG onwards, you have learned numbers. So once again we discuss numbers. The perfect definition of number is a mathematical expression which is used to count. Number is a mathematical expression which is used to count. Here 1, 2, 3, 4 so on or numbers. 1, 2, 3, 4 so on or numbers. Numbers are classified into different types. Numbers are classified into different types. The first one is natural numbers. First one is natural numbers. First one is natural numbers. A number which is starts from 1. A number which is starts from 1. Those numbers we can call it as natural numbers. A number which is starts from 1, those numbers we can call it as natural numbers, and natural numbers represented by capital N. Natural numbers represented by capital N. So N is equal to 1, 2, 3, 4 so on. 1, 2, 3, 4 so on. Here in this set, in this natural number set, the 1 is the smallest natural number. Here 1 is a smallest natural number and there is no greatest natural number. There is no greatest natural number. In our daily life, daily we are entering the class and in our class teacher daily taking attendance. While taking attendance start from 1. Rule number 1, 2, 3, 4 so on. Next in our class counting the benches. We can count the benches starts from 1. 1, 2, 3, 4 so on. Those are examples of natural numbers. Next the second one is whole numbers. The second type of numbers is whole numbers. Whole numbers. What is whole number? A number which is starts from 0. A number which is starts from 0, or if we include 0 to natural number set. If we include 0 to natural number, that type of numbers we can call it as whole numbers. The type of numbers we can call it as whole numbers. Next, whole numbers are represented by capital W. Whole numbers are represented by capital W. The whole numbers starts from 0. 0, 1, 2, 3, 4 so on. This is a set of whole numbers. In this set, 0 is smallest whole number. 0 is smallest whole number and there is no greatest whole number. There is no greatest whole number. We can't find the greatest whole number and we can't find the greatest natural number also. Okay. Now, the third type is integers. The third type is integers. What is the definition of integers? The combination of positive numbers and negative numbers along with 0 is called integers. The combination of positive numbers and negative numbers along with 0 is called integers. Okay, so here for example in our daily life, temperature, day to day temperature is decreasing or increasing. In winter season temperature is decreasing. In summer season temperature is increasing. Like that we are using some negative, some positive values. So other time we are using integers. So integers means what? The combination of positive numbers and negative numbers along with 0 is called integers. Next, integers are represented by capital I or Z. I or Z. Mostly we are using Z. In higher classes we are using I. Now I or z, the set of integers are so on -2, -1, 0, 1, 2, 3, so on. Okay now. So here minus infinity starts from minus infinity. We don't know the where is starting number. Here -2, -1, 0, 1, 2, 3, so on. So here the combination of negative numbers and positive numbers along with 0. In this set there is no smallest integer and there is no greatest integer. Here we don't know smallest integer and we don't know the greatest integer. So then now what is the smallest integer? Undefined. What is the greatest integer? Undefined. Next type of numbers is rational numbers. Rational numbers. What is meant by rational number? A real number which is expressed in the form of p by q, where q does not equal to 0. That type of numbers we can call it as rational numbers. So here what is meant by p by q? P by q is in fraction form. We know p is numerator, here q is denominator. So for example 1 by 2 is in the form of p by q. Here 1 is numerator and 2 is denominator. So if q does not equal to 0, here q is does not equal to 0. If q is equal to 0, what happened? 1 by, in the place of 2 we write 0. It is undefined. Okay, so we can't find the value of 1 by 0. So this is not a rational number. So what is that? What is meant by rational number? A number or a real number expressed in the form of p by q and q must and should does not equal to 0. Those numbers we can call it as rational numbers. Let us take examples of rational numbers. Here 1 by 2, 1 by 2, 1 by 3, 6 by 9, 7 by 4, so on. These all examples are in the form of p by q. 1 by 2 is p by q, 1 by 3, 6 by 9, 7 by 4, so on. These all are examples of rational number. Next, rational numbers are represented by capital Q. Next, coming to irrational numbers. The next type of numbers is irrational numbers. Irrational number. What is meant by irrational number? A number which is not expressed in the form of p by q. Where q does not equal to 0. Those type of numbers we can call it as irrational number. Now, what is the examples of irrational number? Here, one more thing. Roots of all prime numbers we can call it as irrational number. Already we know the prime numbers 2, 3, 5, 7, 11, 13, 17, 19, so on. These all are prime numbers. If we include root 2 prime numbers, means root 2, root 3, root 5, root 7, root 11, root 13, root 17 and root 19. These roots of all prime numbers we can call it as irrational numbers. These all are irrational numbers. Next, here irrational numbers are represented by q dash. Or sometimes s. Irrational numbers q and irrational numbers represented by q dash or s, and root of all prime numbers are irrational number. Root of all prime numbers are irrational number. Now we are going to discuss about how to identify rational number and irrational number. For example, the given fraction is rational number or irrational number. How we can identify? Let me see. Rational numbers. Rational numbers are divided into two types. The first one is terminating. The second one is non-terminating. First one is terminating and the second one is non-terminating. Here what is mean by terminating and what is mean by non-terminating? Terminating means what? Terminating means non-repeating, not repeating. Okay, terminating means non-repeating. Non-terminating means repeating. Here write terminating means non-repeating. Next, non-terminating means repeating. This is repeating. Non-terminating means repeating. Now say non-repeating and repeating. So here non-repeating means, for example, we can take 1 by 2. Let me check 1 by 2 is rational number or not. Let me check 1 by 2 is rational number or not. So when we divide 1 with 2, here 2 0 point, we can take 0 here. 2 5s are 10, the remainder is 0. In quotient place, here decimal is end. So here decimal is non-repeating. This type of decimal we can call it as non-repeating decimal. Now remember that non-repeating decimals means what? Terminating decimals. Here all terminating decimals are rational numbers. So in this case 1 by 2 is rational number or not? 1 by 2 is a rational number. Why? Because when we divide 1 with 2 in decimal place, in quotient place 0.5, it should be end, not repeating. So this is a non-repeating decimal. Non-repeating decimal means what? Terminating. All terminating decimals are rational number. All terminating decimals are rational numbers. Next, coming to non-terminating decimals. Non-terminating means what? Repeating. Repeating. In this repeating, we have two cases. See, in first case 22 by 3. So when we divide 22 with 3, 3 7s are 21. Here remainder 1. We can put point and 0. Here 3 3s are 9. Again 1 0. 3 3s are 9. 1 0. It is going continue. It is continuously repeating with the same number. Here repeating continuously with the same digit. Here 7.3333. So we can write as 7.3 bar. So it is repeating or non-repeating. It is a repeating decimal. But it is a repeating decimal. But after decimal point, the same number is repeating continuously. When after decimal same number is repeating continuously, this type of decimals we can call it as recurring decimals. We can call it as recurring decimals. What is recurring decimal? After decimal point, the same number is repeating continuously. those type of repeating we can call it as recurring. Okay. One more type of recurring is mixed recurring. One more type of recurring is mixed recurring. This mixed recurring is, I am going to explain with one example. Say 5 by 18. For example, we should take 5 by 18 is a fraction. If 5 is divided with 18, if 5 is divided with 18, here take a 0 point decimal, here 0, 18 2s are 36, 18 2s are 36, the remainder is 14, we can add 0 here. Next 18 7s are 126, 18 7s are 126, again remainder 14, we can add 0, again 18 7s are 126, again the remainder is 14. So here we got 14, here we will get the 14 is continuously. So here the in quotient place after decimal 0.27777. So here 7 is continuously repeating. 7 is repeating continuously. So we can write 0.27 bar. 0.27 bar. So why we can call it a mixed recurring here? After decimal, after one digit, the digit is repeating. After one digit, the next digit is continuously repeating. So this type of recurring we can call it as mixed recurring. Here recurring, this is mixed recurring. In recurring, directly after point, one digit is continuously repeating. But coming to mixed recurring, after point, after decimal point, after one number or after two numbers, here the digit is repeating continuously. The more example of mixed recurring is 0.2.5777 so on, here 6.9444 so on, and 7.8444 so on. Like this type of examples, these are examples of mixed recurring. Now this recurring decimals and mixed recurring decimals are rational numbers. Why? Because these two are repeating decimals. Repeating means non-terminating. Mixed recurring decimal. Now here one more type. For example, here what is non-recurring? These two are examples of recurring. Now what is non-recurring decimal? Now what is non-recurring decimals? Here recurring decimals means after decimal point the number is continuously repeating. Here after decimal, after one digit, the digits are repeating continuously. But in coming to non-recurring decimals, it is after decimal point the different digits are repeating continuously. The different digits are going on continuously. Means, for example, root 2 is equal to, the value of root 2 is 1.414213 so on. The value of root 2 is 1.414213. Here once we observe in recurring and in mixed recurring, here after decimal point continuously repeating, same number repeating here. Here after decimal different numbers are going. This type of decimals we can call it as non-recurring decimals. Let us find one more example here. The value of pi. Daily in our mathematics, daily we are using pi. So the value of pi is 3.141592653 so on. 953 so on. The value of root 2 is 1.414213 so on. The value of pi is 3.141592653. Here not repeating any digits. So here 4 1 4 2 1 3. So we are unable to write a bar here. These two cases, root 2 and pi, and here golden ratio also one of the example of non-recurring. Golden ratio also one of the example of non-recurring, and one more Euler number. Euler number also like this. Different digits are repeating after decimal. These all are examples of non-recurring. Now finally, so all non-recurring decimals are irrational numbers. All non-recurring decimals are irrational numbers. Irrational numbers. Irrational numbers. So now in rational numbers we have three cases. Here the first case is directly in the decimal places we got the remainder 0. This is not repeating, means it is a terminating decimals. So all terminating decimals are rational numbers. In coming to second case what? Recurring. Second case is recurring. Recurring means repeating. Here repeating means after decimal the same digit is repeating continuously. And one more case in this recurring, one is mixed recurring also. Mixed recurring means after decimal, after one decimal or two decimals, the next digit is repeating continuously. So here recurring decimals and mixed recurring decimals. These two types also we can call it as rational numbers. The next case is, the last case is non-recurring. Non-recurring means after decimal not repeating same number here. Not repeating same number. This type of numbers we can call it as irrational numbers. Now the combination of rational numbers and irrational numbers is called real numbers. In our 10th class first chapter, real numbers. In our 10th class mathematics first chapters, real numbers. What is mean by real numbers? The combination of rational numbers and irrational number, we can call it as real numbers. The real numbers are represented by capital R. So R is equal to Q union S or Q union Q dash. Q union Q dash. Why we are using union here? Union means combination. Combination of rational numbers and irrational number is called real numbers. So R is equal to Q union S or Q union Q dash. So this real numbers we can start next class.